Okay, so in this video I'm going to discuss the disk method regarding rotating around the y-axis. But before I do that, I want to explain that we've been using the disk method for so far about finding solids of revolution around by taking a region and revolving it around the x-axis. But really, we can use this method, the disk method, to find the solid of revolution around any axis, vertical or horizontal. So what we're going to do is we're going to start with the y-axis and say, okay, what if I want to take the region and rotate it around the y-axis instead of the x-axis? What solid does that create, and what's the volume of it? Okay, so in this definition, so if we're going to do that, well, this is the rule by which you go by. So you let g of y be a continuous and non-negative, then define the region Q bounded on the right by g of y, on the left by the y-axis, below by the line y equals c, and above by the line y equals d. And then the volume of the solid of revolution formed by revolving Q around the y-axis is going to be given by this function. And so it's very similar, right? So everything is just in terms of y, and we've seen that before. So you can, the function needs to be in terms of y, and the derivative is in terms of y, or the differential is in terms of y. Okay? And so the limits of integration are also in terms of y. Okay? So in essence, just again, how do we get here? Think about what we did to derive or talk about the disk method. So in the case that we're revolving around the y-axis, well, guess what? The rectangles, the radius, right? We're revolving around the x-axis, or excuse me, the y-axis. So now we're going around the y-axis, so our rectangles are now vertical, right? So now the radius, right? So the radius of the disk is now determined by g of y. And the thickness, or the width of our rectangle, is delta y, which becomes dy when we integrate, right? When we take the limit. We've already talked about Riemann sums, right? And so it should not be hard for you to see where now the radius of our disk is determined by the function g of y. Our width is dy. And so again, if we take the area formula, what? It's still pi r squared. In this case, r is now g of y. So it shouldn't be a surprise that we get to this formula by revolving about the y-axis. Okay? So we're going to do some examples, and I'll see you then.